Hello friends, we have a wonderful programmer called IO-Flasher from IO2 Micro Solutions. This programmer is available for STM8 and STM32 both. This programmer comes into different variant. You can see I have two variants with me. One is IO-Flasher Pro Plus. The second one is IO-Flasher Pro for STM32. So both are for STM32. One is Pro Plus, this one is Pro Plus, and this one is Pro. So the basic difference between the Pro Plus and the Pro programmer is that Pro Plus can store multiple hex files in it, and by the navigation of the menu, you can navigate those files, you can select it, and then you can program accordingly. This is a major difference between Pro Plus and Pro. Rest of the features are same. So today we will see how to use IO-Flasher Pro and Pro Plus both to program the target board. This is a standalone programmer, so majorly used for production purpose. So let's see how to use IO-Flasher Pro and Pro Plus for STM32. Okay, so to use this programmer, we will need a GUI, which is called IO-Flasher GUI. So here I have this IO-Flasher GUI. Let's open this GUI to see how it looks like. So this is the interface for IO-Flasher GUI. The interface is more or less similar to STVP that ST is having. So we have different features here. So I will cover all the features of this GUI and all the features of the programmer one by one. So let's go with the very basic of selecting a target and then flashing a binary into it. So for that, I need to first select a device. To select a device, I can go to a configuration, set configuration, or I can also go from here, set configuration. This will give me the list of some settings. Here I can select ST or Texas. Presently it's available for ST only. So ST. Then here you can select different families which are supported so far. So as this supports STM8 as well, and also STM32 different families that you can see in the list. The good part is that IO2 is keep on adding these different families regularly, and the updates are available online. You just need to connect your programmer with the GUI, and you will be able to update your IO-Flasher programmer to get the support of the more devices which will be coming up. So here I will select G4 as I am having a G4 on the target port. So if you see in the camera side, we have this programmer which is IO-Flasher Pro, which is connected with a target board, right? This one. So this is connected with a cable which is a SWD cable. So here you can see the sequence of the wires, like this is first one pin is VCC, second pin is clock, third is ground, fourth is SWD IO, fifth is NRST, and this last pin is not connected, it's NC pin. This is actually being used in IO-Flasher Pro Plus PPM version, where we have a clock calibration facility also. In this it is not used. So okay, so we have connected this target board. This target board having IMCU inside, which is STM32G431RP. So we need to select the same device in our G. So let's see. So we have selected this. We can select any device, but now for this experiment, we will select G431RB, this one. Now, depending upon your requirement, you can do different settings. Here we have an offline mode, online mode. In offline mode, when you select this offline mode, your binary, whatever settings you will do, that will be stored in the programmer in an encrypted format. And then without the PC, without the laptop or PC, you can program your target code with the programmer itself, because the programmer has the binary file, has all your settings of the project as well as the optional bytes and other stuff. That all is saved in the programmer itself, so you don't need any a PC and the laptop. In online mode, the file will not save. This will be directly go from your PC to target board, the target MCU, and this will not be stored into the programmer. So this is the online mode. Then you have a verify device. So if you want to verify device, so every device, every MCU have its own ID. So if you want to verify the device, you want to make sure, okay, whatever program device I'm programming is the same device which I have selected. This should not be any other device. If you want to make sure, then you can enable the verification, device verification, as you can disable the device verification. This is a default. This settings is actually not affecting so far, so you can just skip it, as WD is the default protocol, as JTAG is not there. Okay. Then you have this limit counter option. This can be used to limit the number of devices that can be programmed. So this can be enabled or disabled. So if you enable it and you give some count, let's say I'm giving count as 5. That means your programmer will stop programming after programming 5 target boards in offline mode. This works in offline mode only. So if you select 5, after 5 time programming, your programmer will stop programming further, and you need to reprogram your programmer again with the same different setting, so that it can further program your more devices. So you can set any limit, let's say 1000, 10,000, whatever you want, and that will ensure that your programmer is not programming more than these devices. So this is to control programming production quantity, and also sometimes many design house they work on the royalty basis, so they can put a counter here, and for their discount they can charge the royalty to their customer, and then they can give this programmer to them, and after that much count, the programmer will stop programming. They can ship back, and then they can reset the count, or reset the value of the count, right? So then you have a block number option. So this is disabled for the Pro version. This will enable for Pro Plus. So by default for Pro version it's 0 always. So because you have only one section where you can save your binaries in the programmer, so you have 0 only. If you go into Pro Plus version, you will get a drop down list over here where you can have multiple selections from 0 to 12 or 0 to 15, different sections where you can save your binaries. So that we will see in a separate session. So then you have you have power supply settings. It's a programmable power supply section. So you can enable or disable it. When you disable, if your target board is already having a power supply, external power supply is already powered up, you can disable it. And if you want to feed the power supply to your target board through this programmer, then you need to enable it. So if you enable it, then you have option, depending upon different family, you have different options to select. Default 3.3 volt is the nominal voltage of the STM32 family. It is showing the nominal voltage here. So you can select any voltage to set for your target board. You can set any value. Then there is an option called delay before programming, and that is in millisecond. So this is very important part to understand, that if your target board having some big capacitors, right? So probably the inrush current will be more, and whenever you start programming the target board, your target board may show the overcurrent limitation. So your programmer will show overcurrent go into overcurrent protection and will not program the device because of the inrush current of the capacitor. So depending upon the capacitor values, you can set the value, okay, whatever your rising time what you have for your supply. As per your rising time, you can set the timing, maybe 100 milliseconds, second, 1 second, whatever you feel okay, depending upon your size of the capacitor, how much is your rising time of the power supply. This is that can be so you can set any value of the this counter, this timing as per your need. Then we have an option called delay after programming. So this is useful for testing purpose after the programming. So let's say if you want to check some features, okay, that after programming those features are working or not, then you will need a power supply to your target port, right? So if you set this value as, let's say, 10 seconds, as it is there right now. So after programming for 10 seconds, your output power will remain on. So your target will be powered up. To reset your target either by removing the programming cable or by any switch if you have a reset switch on your target port. Because sometimes in many of the cases, especially when you are programming option byte, your target cannot be reset through reset pin. Then in that case you may need to remove the connector and reinsert the connector so that it can have a power on reset, and then you can test your features. So you have to see, it may work in some family, it may not work in some family. So accordingly you have to see which reset is working for you. If power on reset is required, then you have to replug the cable, right? So and then you will have 10 seconds or 12 seconds or 15 seconds, whatever settings you do. For that much time, you will have an output power coming, right? You not need to wait till the end of the timing. You can start the programming of new device also if you have already set this timing on the higher side. Then you have advanced setting. In advanced settings, we will see in the separate session. Then you have erase options. So you by default showing block erase. You can select block erase. This means like whatever the file you are selecting, right, or whatever the size of the flash you are selecting, that is into the flash memory tab here. I will show this thing also. So let me show here only. So you have a option to change the starting address of the flash and also the size of the flash. So let's say if you want to partially, my size of the file is smaller, you can change the size of the file, and then your programmer will only program that section which you will select here. It will leave the other section, and this works along with the block erase mechanism. So if you select whatever the address you select, whatever the size you select in the flash memory tab, which I just shown you, and you select a block erase, only that much size will be erased. Other section of the flash will not be erased, right? So that is the use of the block erase. If you select a complete size in the flash memory tab here, then the whole memory will be erased block by block. And if you want to erase your complete flash, you can select full erase. Then with respect to the size selected on the flash memory tab, it will erase complete flash. And you can also choose no erase if your device is already erased, or maybe it may be a new device which is pre-erased by a factory. Then you also select no erase. The one point to understand that timing of the programming may change depending upon different settings. So if let's say your code is almost covering the complete flash, then you better to select full erase, because full erase is faster in the timing. And if you have let's say a very small code but bigger flash size, Then you can also select block erase, because because you have only few blocks to erase, it may erase faster than the full erase. So accordingly, you need to choose your appropriate option to make the programming time faster. Then you have a verify after programming. So this particular section will help you to verify the code which you have programmed. So it will write the code into the target board and read back and verify it is matching with the data which you already the file which you have already selected, right? So this is always recommended to verify after programming. If you don't select it, the only one benefit is that the programming time will reduce by some value, because you are saving the time which is going for the verification. Then you have an option unprotect before program. So or end the ROP reset before program. So if you select the ROP reset before program, that means if your target is already protected for the read. So you can see here in the option byte you have a read out protection, which is RDP. If it is set to level 1, right, your device is already programmed and it is set to. If you have a device which is already protected and you want to reprogram that device already protected with level 1, because level 2 we cannot recover from level 2. So if it is level 1 and you want to program your device, then you can set this option ROP reset before programming. This will automatically clear the ROP settings from level 1 to level 0 and reprogram the device. And whatever, after programming the device, whatever the option byte you might have selected there, accordingly it will reset or reconfigure the option byte to level 1 or level 2, whatever you will be choosing. Then you have a unprotect before programming. So what does it mean? Like this will actually unprotect your device in terms of other settings also. So if you, let's say you have a write protection enabled, or you have, let's say, PC rope enable, or you might have other protections also within the device. If you select the unprotect your device, this will clear protections, right? So just to make it more clear, the ROP will only clear the read out protection. This will not clear the write protections or the PC rope protection or the other protection. This ROP reset before programming will only reset or clear the readout protection. While if you select this option, unprotect before programming, this will clear all the protections and then it will program the device, right? So because if, let's say, you don't have ROP set and you have only the write protection enabled, then the programmer will not be able to write the flash, because this particular section, any section is write protected, right? So this will help to unprotect those sections from the write, and then it can program it, and then you can again set it by the option byte setting, right? So in this way it can unprotect, program, and reprotect, right? Then you have programming options. So you can select, if you want to program only the flash memory, you can check the flash memory. If you want to program only the option byte, the only option byte option is not there actually. So you cannot program only the option byte. If you do this and you apply, it will show you the error. So you have to select either the flash or both the memory. In some of the MCU you may have EEPROM also. So you can also select EEPROM only and the flash only, but option byte only cannot be programmed. This limitation is because some of the devices may be locked by mistake, and then it may not be recoverable. So you need to make sure that you have programmed the code first before locking the device. That's why we have such option. So after selecting the programming option, you can click on apply. Once you apply, you will be able to see the option byte for the selected device here. And if you want to edit the option byte, you can modify. You can just check on this enable editing, and you will be able to modify these option bytes there. And in Flash, you can see, as I mentioned before, like you can enable the editing for the address and the flash size, and you can change accordingly. So let's say if I change it to this, you can see if I change any value, it will be accordingly, showing size. And if I do something wrong, I try to enter more values, it will give me error as well. Then you can select a file. So I am selecting one file. From there you can select you want to have a binary file or hex file or the S19 file. So let's select binary file. These are some test file which I'm having with me. So I am right now having a device of 128 kilobytes. So I'm just selecting a 128 kilobyte of data size, the file. And then this is some dummy data which I have filled to for the testing, right? So this is having some sequence of some data. So now after this, I can simply click on Alt Tab, Program Alt Tab. If I click on Program Alt Tab, this will load the or the whole settings into the your target board, and then you can see chip program complete very fast. After this, your programmer is now ready to program the target board. So let's go to the video again, so I can show you. So here you can see, I hope this might be visible. You can see the device name which I have selected. It's visible here. The device name. Yes, you can see the device name which I have selected. So now to program the target board, I just need to press on the start button, and you can see the programming has been started. It will show the percentage also, and done. So now my target board is programmed. If I want to verify this, I can simply open QProgrammer. I can connect my target port. So I can show you here. I'm just connecting my target port, removing from the programmer and connecting it to the ST link actually. And then I can just read it from the QProgrammer. So you can see this is the data which I have programmed, right? And these are the option byte that is there, right? This also has been programmed. So I did not change it in the previous settings. Maybe I can change these settings also. So let's change these settings also. So if you see here, let's say write protection, this is 3F or some values are there. I can change these settings and I can verify all bits are set by default here. I can change them and I can verify it is working or not. So let me reconnect to the IO flasher. Okay, now this time I can also change the option bytes. I can change some option byte. Let's say I can change it from 00 to, let's say, 2F, and this I'm changing from 0 to 1F. I'm doing some changes here also, right? So we can validate these are programmed by any programmer or not. And let me also set the limit counter to, let's say, to 3, right? And apply. Then program Alt Tab, complete. Okay. Now I again need to go back to camera. So you can see now we'll press the button. programming. You can see a counter here which is increasing. You can see this. Now it is showing counter 1. So one chip has been programmed. If I press again, counter 2, you can see. If I press again, three. This time this is 3. Now if I press it again, you can see error, counter reached limit, right? So why it is? Because I set a counter as 3, so it will not program more than 3 count. So if I want to further program it, then again I need to go back to my IO flasher GUI. I need to change the value, increase the value, or I need to program it again with the same value. So I can program it again with the same value like this, and now I will be able to program another 3 boards, because you can see the counter is 0 now. I can again program 3 boards, right? And again after 3 boards will be showing the same error and not. That's how it works. Okay, moving forward. So whatever settings you have done in the configuration, those settings are visible here on this right status panel. All the settings you can check here. Then you have some more buttons like read serial number, read voltage, target voltage. If your MCU is powered or already powered externally, then you can read the target voltage from here. How many chips you have programmed earlier, already programmed earlier. You can check it from either from the programmer display, which I shown you, or you can also check it from here. You can just click on read and it will read the value, from the programmer, and it will show, like you can see 1 is here, so the same value it is showing here on the read, right? And then you can also read the serial number. Okay, which serial number has been programmed or is being programmed. So right now it is 00, so nothing is programmed because we haven't enable it. So if I press again, so you can see now this time the serial number is 1, because I am programming 1 chip. So first chip is programmed with serial number 0000, second chip is programmed with serial number 000001, right? Likewise. And okay, now let's go to the advanced settings to check it, to show you how it works. So in advanced settings, you can set any value. So let's say I have a washing machine, or let's say I have a AC with me, which I want to, AC with me, like I am doing the production for AC, so I can give a AC or the model number, whatever I am having, right? And then I can, let's say I have a model number, I can type here also if required, mod, and then I have this thing I can set as a counter 0000, right? Or maybe I can set here A, for example, whatever the value you want to set. And then it's already enabled. I can enable or disable it if you want to program the serial number or not in target code. I can give the value here, that value where I want to store the serial number in flash, right? So whatever address I will give here, at that address the serial number will be stored. Default this is giving you the value starting from the end address. You need to make sure this address should be within the range of the memory which you have selected in the flash memory. This should not be out of that range. If you are modifying the flash memory size in the flash memory tab, then this particular address should be within that limit. It should not be out of that limit, because programmer will be programming only that flash, right? So as we have a complete flash selected, so we are keeping it within the flash. Then increment by 1, what we do, so if you make it 1, that means on each programming, the serial number will be incremented by 1, right? You can also make it 2 or 3 or 4 or whatever value you want. And what is the use of this? With this feature, you can, simulate the gang programming feature. So let's say you can buy 2 programmers or 3 programmers. In in programmer 1, you can set it increment by 3, let's say, and and you can also in the programmer 2 again you can also increment by 3, but the serial number you will change by 1, increment by 1 by default. And in programmer 3 again you will increment by 3, but you will change the serial number to 2. So what will happen, from in program number 1, it will start from 0 and then increment by 3. In programmer 2 it will start from 1, increment by 2, and then programmer 3 will start from 2 and increment by 3. Same. So in this way, your each device which is programmed from different programmer will be having a unique. Then you have manufacturer data. So here you can enable it. Again, the address is there, which again has to be within the flash memory range. Size you can select, by default is 256. You can reduce it also. The maximum is 256. And here you can give whatever the batch code, batch number, or maybe the production date you want to give, in case date if you want to give, right? Let's say today is 05th Jan, right? Or let's say you want to give anything, like whatever you feel okay, it's added into production flow, that you can give here, and that will be stored within your MCU flash at a desired you have selected here, right? Then this section, the clock settings, is available only in the Pro Plus PPM version. So this is not selected or not enabled here. Then you can also use encryption keys generation. So this is very helpful for the IoT applications where you need to have a secure communication and you need to program a individual or separate key on each target port, so that it can communicate with the server securely. So how it works actually, whatever address you will select here, right, that address will be programmed with some keys. The size of the keys can be selected here, and the number of keys that you want to generate, up to 5, you can generate up to 5 keys, can be selected from here. How it works actually, if you're using for the IoT application, how it will work. So let's say I want to make my IoT application is secure. So I will have a default key, right, which is a provisioning key or default known key to the server, right, and that key will be common to all the devices actually, right. So this is stored in all. It's a part of your binary itself, you can say, in this way, right? It's part of your binary which you have generated from your source code. Then once you will turn on your device in a secure environment during the production, right? In a secure environment, you will turn on your device for testing purpose, like you will doing it in the in your production flow. It will be turning on, and it will be connecting to a cloud with a known key which is already in the device. Now for the once you will interact with your server in a controlled environment, it will exchange these new keys, right? These new keys which you have generated, it will exchange those keys with server, and the further communication will be switched to that those keys, right? Then your first key, which is being used by the device, will not be used again. This is only one-time use for the production. And now in this way, your each device will have a separate key, which is only known to the server. So how it will be happening, like during the provisioning, during the first production provisioning, I should say, your device will be sending any of these or all keys to server by encrypting it with the known key, right? So that server can decrypt those keys and save it for the further uses. And once your product in the field, then you will not be nobody will not be able to know the keys which are dynamically generated and stored in the device, right? So only your server knows about those keys. Even the guy who is doing the production, even that guy itself don't know what is the key that has been used in particular device, because each device will be having separate keys, and those has been communicated to server only during the provisioning, production provisioning, right? So that's how these keys works. So I can just select this enable, and then I can just select, let's say, 5 keys or maybe 256 keys, 5 keys of 256 bit long, and apply. And then again I'm doing, and here I have already changed the settings, and I'm just programming the target port in an offline mode. Complete. Now if I just need to, one more thing, we can also, rather than pressing the button on the programmer, I can also click on the SIM key. This will be doing the same function, same feature as pressing this key, right? This is available for offline mode. Let's see, if I have PC, you can just press on SIM key. So I'm pressing on SIM key. This is same as pressing this start button. Just programming the target mode. Again, I can press it. You can see offline mode, offline MCU programming. I can read target port also, voltage also, 3.3 volt. Why it is 3.3 volt? Because I set a delay after programming at 10 seconds. So till 10 from here, you can see 2, right? Now, whatever the settings I have shown you, advanced settings, I can verify with the help of the programmer, right? Q programmer, right? So let's see. Let's open the Q programmer now to check how it is working. Let me connect the board back to the ST link to verify and to validate. So I'm just connected the board. Now you can see, you can read. Okay, so I think I could not select the file. Yeah, file is not there, so I need to select the file. I'm reprogramming it, and advanced setting, everything is in place. I am reprogramming, connecting back to the programmer. And then pressing the button. Okay, again. To show you the counter value in the flash memory, that's why I'm doing it. So I'm removing it, opening Q programmer. And then connect. So you can see the file which I have selected, same file. If I go in the end, you can see the values which I have stored, like batch number, date, right? And here you can see the counter which I stored, and these are the encryption keys that we have written, right? It's a random number, you can see. So this is what is happening, and if I go in option byte, you can see the value here 2F, 1F, which I have been set before, right? So this is how you can program the serial number or manufacturer data as well as the encryption keys.